Homework 1.6, other types of equations, video 1, homework due on Saturday, May 16th, 2020 at 11:59 p.m. I think I'll start writing that part. So don't text me at 12:02 in the morning and say, I didn't finish my homework. Okay, so this next section is kind of a dumping ground for things that don't fit elsewhere. Any section that says other types of, you should be a little leery of. It doesn't mean it'll be difficult, it just means it's a mishmash of different types of equations, or whatever the objects are in the section. In this first video, we're going to be looking at polynomial equations. Now, these are similar to the quadratic equations that we saw before, but the main difference between them and what we saw before is that quadratic equations, by definition, have a highest power of x squared, whereas a polynomial equation has no limit on how high the power can get. Now at this juncture, there's only certain types of polynomial equations that we're capable of solving. Later in chapter 3, we'll learn a massive technique. Well, it's not a massive technique, but it's a super universal technique that'll attack any size polynomial equation. But for now, let's take a look at a specific example. Let's solve 3x to the fourth power minus 108x to the second power is equal to 0. Now, if this were in quadratic equations, we could solve it by using factoring or trying to use square roots or complete the square of the quadratic formula. And of those four techniques, only one of them is a little bit more universally applicable than the others. And that would be the first technique, solving by factoring. The whole premise about solving by factoring is not contingent on the equation being quadratic, but rather the equation being factorable in general. So for any size polynomial equation, as long as we can get it equal to 0 and factor, we can get something done. So I went ahead and briefly summarized the steps for solving an equation by factoring. This is just like what we saw earlier in these series of videos for quadratic equations. It was either in the first or second video where I wrote out the steps, but in a nutshell, you get the equation equal to 0, you factor it, you set each factor equal to 0, and then you solve. Now, because these equations can be different sizes, there may be different factoring techniques that we need to resort to. So if you're unfamiliar with different factoring techniques, I recommend going and watching the videos in the second module about reviewing factoring, Okay, so let's take a look at this one. If we go through our list of factoring techniques, and they were in order, GCF, grouping, trinomials with a 1 in front, trinomials with a different number in front, and difference of squares, the first thing on that list is first for a reason, greatest common factor. These two terms have a common factor. If you're not sure how to factor out a greatest common factor, please go watch the first video in the second module. But for both of these terms, they're both divisible by 3. The 108 might not be obvious, but this can only be factored out by 3. So you might want to investigate 108 divided by 3 and find out that it is a multiple of 3. There's another trick to see if the number is divisible by 3. If the sum of its digits is divisible by 3, the sum of these digits is 9, which is divisible by 3, and so is 108. So I will be able to factor out of 3. But what about x's? The x is in common, and when factoring out a variable that's in common, you use the least power. So we're going to factor out an x squared. We're essentially doing the distributive property backwards. So let's figure out what needs to go here so that if we were to distribute, it would take us back to the beginning. Factoring is just another way of dividing, another way of saying dividing. So when you're factoring out a 3x squared, you can figure out what's in the parentheses by literally dividing each term by 3x squared. Or think of them as fractions that you can reduce. In the first fractions, the 3's cancel, and then we can subtract the powers. X to the fourth divided by x to the second is x to the second. And in the second term, 108 divided by 3 is 36. And x squared divided by x squared, the x squareds cancel. So when we factor out a greatest common factor, we get 3x squared times x squared minus 36. When you're factoring, you should always ask yourself, can I factor further? Now this being a single term, there's really not much I can do with it, so it's going to stay at 3x squared for now. But the second factor, the x squared minus 36, is a difference of squares. And if you're not sure what that means, go watch the 5th video in Module 2. Since x squared is a square, we can write x times x there. And since 36 is 6 squared, we can write 6 and 6 here. One of the factors gets a minus, one gets a plus. At this point, there's no more factoring. But whenever you're doing multiple factoring moves, you should always ask yourself, can I still factor? And if there's an x squared, the answer is always maybe. But at this point, we've got it equal to 0 and we've got it factored, which means we can just set each factor equal to 0. 3x squared equals 0, x minus 6 equals 0, and x plus 6 is equal to 0. And then just solve each one, the last two of which are easy. Subtract 6 on both sides, and we get x equals negative 6. Add 6 on both sides. Got to be careful, my zeros are starting to look like 6s. Add 6 on both sides, and we get x equals 6. But what about this guy? 3x squared equals 0. Well, technically, it's a quadratic equation with one x term. So we can solve it by just using square roots at the right time. Not yet, because the squared part is the x. So before I get out the square root, I would want to divide both sides by 3. Well, 0 divided by 3 is 0. And then break out a square root on both sides to cancel the square, and don't forget the plus minus on the other side. The square root of 0 is 0. Wait a minute, positive 0 and negative 0. 0 is the only number that's equal to its opposite. In other words, if I stand at the middle of a number line and go 0 spaces to the right and 0 spaces to the left, I'm still in the same place. So plus minus 0 is redundant. If it were any other number, we would need the plus minus. But because it's 0, we don't need it. So 0, 6, and negative 6 are our solutions. So we got 3 solutions. I'm going to do another example of polynomial equations, but in an attempt to keep these videos reasonably shorter than the previous module, we'll do the next example in its own video. So even though this module will probably have 8 videos, they'll be short by comparison.